Okay, hello everyone. My name is Timothy Lee Grant, and today what I am going to be trying to investigate is the topic of decorators. So that's what I'm going to be looking at is the decorator design pattern, trying to understand what is it, how does it work, what is it useful for, and along the way I also want to figure out, okay, well, I know that there's something called interfaces, and I have an idea of kind of how they work. They are forced methods that allow you to say, hey, this class, when it inherits from an interface, it forces you to create methods for those uh, interface items. And then you are able to create multiple, or you are able to like select for the class that you want, and all you need to know is that it is of type interface. So I'm trying to work through some of these things. Anyways, that's where we are going. Let me make myself a little bit smaller, and let's just go to Copilot and say what we're trying to do. So I want to start learning about the decorator design pattern. Uh, Give me as much information as you can on this design pattern so that I can understand what it is, how it works, why it is important, and any other information. Give a full example in Java. Okay, there we go. Let's see what it says and then try to implement it. While it's thinking, I will have a sip of water. All right. Let's see what it says. So, decorator design pattern. The decorator design is a structural design pattern. Okay, so I remember a long time ago when I was looking at design patterns, there were different types of design patterns, and structural design pattern was one of them. I forget what the other ones were. That might be a follow-up question that we need to ask is, well, what were the other like sections or groupings? There we go. That's the word. Groupings of patterns. I know that there's like factory pattern. I think that one is a constructor pattern, like a constructor, a group, which is the constructor pattern. So that might be a follow-up question that we address later, but let's not get too lost right now. Let's say, okay, sure, it is a structural design pattern. Awesome. That allows you to do what? Dynamically add behavior. So this is what this pattern allows me to do, is dynamically add behavior to objects without modifying their original code. Okay, so we're not going to be modifying the actual code of the base class. I think that's what it's talking about. It's a powerful alternative to subclassing. Okay, so it is not subclassing. It's an alternative to subclassing. Okay. Key components. Number one, component interface. So here we go with the interface, right? Defines the behavior of the class, concrete component, the object or the original object you want to enhance. Okay, so we're enhancing something, maybe decorating. Is that right? We're decorating it. Decorator wraps, okay, wraps around the component, which is this one, component. So the decorator wraps around the component and adds behavior to it, okay? And then concrete decorator specific wrappers that add functionality. Okay. So why is it important? And it says, first off, the open closed principle. You can extend behavior without changing existing code. Extend behavior means I can add or increase the amount of methods available to me in an object without changing the existing code. Okay. Flexible composition. So here's another one that we might need to look into is composition, because I know that's something else, I believe. So what is composition? How does that work? You can stack decorators in any order. Okay, that's another question. So I know that I can like have a base class and then a decorator and a decorator, but does it matter if I have base class decorator A, decorator B, or base class decorator B, decorator A? Does that matter? Okay. Avoids inheritance explosion. No need to create dozens of subclasses for combinations of features. All right, so imagine ordering a pizza. You start with a base pizza, okay? You add toppings like cheese, olives, mushrooms, okay? Each topping is a decorator. It wraps the pizza and adds flavor, okay? So we define a common interface. So here's an interface and create a base implementation, okay? Plain pizza. So create an abstract decorator that implements the same interface. Create a concrete decorator that extends the abstract decorator and adds behavior. Well, I might need to go back and reread that. Let me come here and kind of look at this code, and we're going to write this code like by hand, okay? So I'm going to come here, just say, I don't know, okay, there we go. So, and can just go like that. We are going to have a public interface, okay? Interface, and we're going to call it coffee. No, I do not want to upgrade right now. Coffee, okay. So one interesting thing is it's not kind of like that. Interfaces don't have those brackets, okay? Interesting. And now what I can do is string, okay, get description, okay, and double get, whoops, cost, okay? So, why is that? There we go. All right, so we have this interface, and now this is another thing that I need to focus on because I feel like it's pretty important, and it's something that when this is kind of how I'm doing my thing right now, is I'm looking at open source projects and just looking at as much code as I can and saying like, hey, I don't quite understand this. And then I will hunt for, like, maybe I'll watch a YouTube video and be like, okay, well, what's going on with this? Is it a nothing burger or is it actually kind of important? And I kept seeing this interface, and I was like, what is this? Come on. Why are we doing this? Why don't we just have the class itself? So that's something that I have in my head, like, hey, interfaces are pretty important. And then I was coming into decorators, and I'm like, okay, well, then I saw that was a big topic, and I'm like, all right, let's go. Let's make a video. Let's dive into it. Let's try to figure out what's happening. So, okay. Now we have a concrete, nope, is it this one? Yep, okay. Concrete component, okay. So now I have a public, so now I have an actual class called simple coffee implements coffee. Okay. Why are you like that? You should be okay, right? Must. Oh, because I haven't done these two here, right? Yeah. Okay, both of these. So I think it's forcing me. So here, let me come here and copy this and go like that. It should. I need this, right? No. Wait, why is this? What's wrong? I need to move myself. Okay. Public class. The public type coffee must be defined in its own file. Wait, why? Okay, I wasn't quite expecting this error. I remember when I. Okay, my computer just froze, I think. All right, so I wasn't quite expecting that error. I remember that it has to. Java like forces you to have the same. Okay. I remember something about this. I cannot remember what the rule was, but I know that we need to create the file name to match the class. When I attempt to, I don't think this is the way it's done in C#, right? I need to confirm that as well. So, what was the first question we were going to ask? It was, okay, so number one, and this is going to be question number two. So question number one is going to be here. So, it was structural design pattern. Okay, so I am going to say Decorator design pattern is a structural design pattern. What are the other groups of patterns? Okay, so when I attempt to put all of those classes in the same file, I am getting an error. And let me just see what that error was again. The public type coffee. Can I copy and paste this? Yes, I can. Okay, cool. Like this. Can you tell me why this is occurring? I want to understand, the concept behind it. And then I want to ask, like, I don't remember this being a thing in C#. I don't. I don't remember this being a problem in C#. Is that the case? Okay. So let's see what it says. Let it do its dancing, you know. Have a little party. Okay. So, oh my goodness. I really hate how it bounces all over the place every time you press enter. Okay, so I just want to know about C Sharp. You do not have this restriction. In C Sharp, you can define multiple class. Okay, yeah, in the same C Sharp file. Yeah, the name doesn't have to match any class name. The compiler handles this more okay, so yeah, that's it's just a Java the oddity. Okay, this reflects a different philosophy. Java embraces strict structure and clarity. C Sharp emphasizes developer flexibility. Okay, so these are the design patterns, which we're going to get to later. I'm not even going to look at them until we go back up to the code and work our way down, because I don't want to get too sidetracked. But I do want to know, like, okay, well, why is this not working? Because that's getting in the way of doing the code. Okay, so why does Java require public classes in separate files? This happens because in Java, each public class must be in a file named exactly after that class. So if you write public class simple coffee, it must be in a file named simple coffee. So that's kind of what I was meaning, that the files needed to match. But I remember running into that problem when I first started kind of playing around with Java, and then it just like never reoccurred. Like I never ran into that problem again, because every time I created a class, I just put it in the same file. But then this is the first time that it has reared its head again, and I'm like, yo, I kind of remember doing this a long time ago, but I don't. Now that I have a little bit more context in the Java world, I'm like, okay, well, now I can kind of understand it a little bit better, because a long time ago when I was first jumping into Java, oh my goodness, I remember I was so confused. It was like, okay, what is Spring Boot? What is dependency injection? What are all of these different paths? Like, there was so much going on. Now I have a little bit more context, so I can understand things better. And so it's nice to be able to go back and visit some of these things. So Java forces you to maintain clear organization in large projects, make compilation and class loading predictable, avoid naming conflict across packages. Okay. So just have them match, essentially. Option number 2, remove public from all but one class. Okay, so it has a problem with public. It doesn't like that it's public. Okay. The second question, the follow-up question, and we're going to come back up to this code up here, but it just came into my head, is can you tell me how this plays in with the idea of namespaces? Compare and contrast with C Sharp. Okay. Let's go. I have another sip of water. Okay. All right. So, okay. In C Sharp, a namespace is a logical container for classes, interfaces, enums, etc. It helps you organize code and avoid naming conflicts. You can define multiple classes in the same file or namespace. So I have my a certain namespace, right? And my app models, okay, and then I have public classes. Okay. In Java, there's packages, right? We knew that. Instead of namespaces. So there's some connection between packages and namespaces. Again, we kind of knew that, but like, what are the actual differences? A package is a logical container, but Java enforces stricter file structure rules. Each public class must be in its own Java file named after the class, okay? So key differences, keyword is package versus namespace. File structure, one public class per file. In C# you can have multiple. Folder mapping. Okay. Packages. So we're in Java right now. So package name must match folder structure. Namespace can differ from folder. Okay, that makes sense. Access modifiers, so packages, okay, whatever. Import, so this is just how you do the different like imports. You can have import and then this package, so com my app models user, but then in C# you just say using and then the namespace that you want to be inside of. Okay, so we always need to have the package as well, so I forgot about that. So let's come back up here and let's kind of just fix these things. So do I need what about interfaces? User, I'm not sure. Do I need to have an interface in its own thing? Like, so what if I did like coffee one? Is it fine? And then package coffee one. Does it not like that? Can I go coffee, this? Okay. Does not match the expected package. Okay. Com my app models. Okay, come on now. Do we just switch to C# to do this? Like, okay, do I need com.myapp.coffee, and then do I need to come in here, do com like that, and then inside of here say my app, okay, and then inside of here put that there. Move. Okay, sure, whatever. And now it's happy. Okay. Oh my goodness. My goodness, this was a lot more difficult. just getting started. We haven't even got to the part where we're actually implementing anything. Okay. Now we are going to be creating that was SQL back when we were in the last video investigating SQL. Here we go. Okay, we are back on track. So we are going to be implementing this simple coffee. So I'm going to call it simple coffee.java. Okay, and now notice it's my app. It's not my app dot. Oh, this one is my app as well. Hold on. Okay, I'm sorry that I'm going all over the place, but look at this. It goes models. Oh, never mind. I was thinking that this was the last, so I don't need to do that. I don't know if I'm doing this just completely wrong. I guess when we compile it, we'll figure that out. So we can deal with that later. Let me come in here to simple coffee. I have my public class And I'm just going to do that here so we can read it. Okay, and then now I want to implement coffee, and that will probably give me an error because I need to import the coffee interface, but we'll fix that. Implements coffee, okay. So the type, simple coffee, must implement the inherited abstract method. Yeah, so it's telling me that I haven't implemented those two required interfaces. So they're here. Okay, so let me copy that and paste them into there. All right. So now I am going to say this is public string get description, and now I'm going to do the implementation of it. Okay. So what does it actually say to do? Return and then simple coffee. Okay. And get cost, this will also be public double get cost and return, I don't know, it's a double, so 2.0. Okay. All right. So now we get this coffee decorator. I don't want that there. Coffee decorator dot Java. Okay, and we have the same package right there. And we are going to say implements coffee. I also noticed I didn't need to actually import it, and I think it's because we're in the same package. But that's going to be a follow-up question, right? Because normally, what I was doing with my Java projects is I was always using the Spring Boot initializer and just like kind of copying that and putting it into my project and then building on top of that and working with Java that way. And now I'm doing it kind of by hand again. And so it's reinforcing a lot of those skills that I kind of I did a long time ago. Okay, it feels like a long time ago, but actually when I look back on it, it's probably about 5 months ago. Because it was right when Susie started at Amazon. And that's when I started learning Java and really kind of trying to get into it. Was when she started. And she's only been there for about 5 months, so it feels like a lot longer. It feels like 3 years ago, honestly. Like, oh my goodness. But where was I going with this? I forgot where I was going with this. Anyways, oh, right, reinforcing those skills that previously I investigated at the very beginning, but have not touched since. So let's kind of get back into it. I think it's because it's in the same namespace. So I can implement coffee here. And I don't think, what was it? Java, right? Sorry, not Java. JavaScript, you need to say like export and then coffee decorate, right? Like that. I don't think you need to do it in Java. I think we're good. So, but we need to implement. Let me put myself down here. It's kind of a weird angle, but implements. Okay, coffee. Okay. Now, actually, I don't like this is such a weird angle. I'm like looking right down. There we go. Now I'm kind of looking more at you guys. Okay, so we are going to have, so we have a public class. So we can have multiple public methods within the class. and that's no problem. It's that we can only have one public class. Okay, so we're going to have protected coffee, decorated coffee. Okay. This is dependency injection. Is that true? I don't know. I don't know. So public abstract. Oh, okay. So we missed abstract class. Okay. Hold on. Why was it? Oh, whoa, whoa, whoa. Why was it an error before though? What's wrong with this? Hey. Implements coffee. Oh, just because we haven't implemented the. Okay. That. Never mind. I thought we happened upon a. But why did it go away there? Why did it go away there? Because, so implements coffee. Okay. This does not give me an error, but when I take away the abstract keyword, I do get an error. Can you tell me the concept behind this? Okay. We are long down here. All right. So absolutely, this touches on a core concept. Abstract classes versus concrete classes. Okay, so I need a abstract classes. What is that? That is classes that are forced to be inherent. So like you can't instantiate an abstract class itself. You have to inherit from the abstract class. So this abstract class also inherits from coffee. Again, not a class, but an implementation. Okay. But it can't be implemented, or it can't be instantiated itself. It needs to instantiate, or it needs to be inherited from a different class, and that other class will be instantiated. Okay. And how interfaces work in Java. Let's unpack why removing abstract caused an error. So the concept, abstract classes versus concrete classes. Coffee is an interface, that's correct. This means any class that implements coffee must provide concrete implementations of all its methods. Get description and get cost. Good. Coffee decorator is an abstract class, okay, with no implementation yet. This is allowed because abstract classes can implement interfaces without providing method bodies. The idea is that subclasses of copy decorator will implement. Oh, okay, so it's going to force the child to implement those methods. So Java says, okay, you're abstract. I won't expect full method definitions yet. Okay. What happens when you remove it? Now Java expects the concrete class, meaning you have to implement all of those interfaces. We cleared that up. Oh my God. There we go. See, we just keep on learning. Can't stop us learning, huh? Okay, so we're back up here. Now we have this abstract class, but we are doing, no, we have this one, coffee decorator. So now let me, so public coffee decorator. So the come on, builder, the constructor, there we go. So coffee, okay. So we are passing in, now this is something that kind of threw me off for a second, for a little while, because coffee is an interface. But when we pass an object into here, we are not actually passing in an interface, okay? Even though this is declared as interface, right? The way I saw people doing it on those open source projects was this, they would pass in an object that implements the interface of coffee. And then you can pass in that instantiated object into here. So this is actually an object. It's not an interface, but it is an object of the implementation of coffee. So you can expect that it has these methods. Okay, that threw me off for a long time. I was like, what? Like, it took me, I don't even know how long, maybe like 30 minutes to try to figure that out. I was so like confused, and then I realized, oh, I think I see what's going on here. All right, we are doing this. We forgot the protected part. So let's protect something. Okay. Protected coffee decorated coffee. Okay. So now this dot decorated coffee is equal to coffee. Okay, so let's think about what we're doing here. So okay, the last time I did a video and I ended up getting a comment. How can you, I forget exactly what the comment said, but it's like, you should learn this in your first day of computer science. How do you not know this concept or something like that? But anyways, so I'm afraid to say like, okay, wait, hold on. Protected. Uh-oh. I might need to look up what protected means. So go ahead and type that comment again. But anyways, whatever. It's fine. As you guys know, my philosophy is, okay, well, if I don't know it today, and I find out, like I go and then I learn it, well, guess what? I do know it today now. So, okay, yeah, I don't quite know protected, because it's not private, right? I know private. It's not final, meaning like you can't change it. So what would protected be? Okay, that's a question. Number one, what does the keyword protected mean? Okay. Okay, so we're not going to press enter yet. We need to get this. So we have some variable, okay? And this variable, we are going to just save it. So this variable is this variable is a member variable to this class, and then I'm saying I pass in an object which has the implementation of the interface, has the contract of the interface here, and then I'm assigning that to this variable. So I kind of captured it, and I can operate on this variable in the other methods. So to do that, public string, and then I can say get description. Yeah, okay. Let's just upset because I haven't returned anything yet. return undecorated coffee dot get description. Okay, and I am, hold on, did I misspell that? No, it's the same spelling. Okay, fine. It's just not highlighting it because it's based off of this object. Okay. So I am assuming that this object here that's passed in has a method called getDescription because it has an interface of coffee. Yeah. So now I'm going to go here and say public double and then get cost return decorated coffee dot get cost. I can do the same thing there. Okay. Concrete decorator. Okay. So now I want to come here and do milk decorator dot java. Okay. And this is going to extend coffee decorator this time. Okay. Extends coffee decorator. Now notice we have extends versus implements. So implement, this is for an interface, right? Interface here. So that's an interface. This one, we say extends because it is coffee decorator here as a class, right there. So we're extending, we're inheriting. Okay. So we come here and extends from coffee decorator. Okay, so what does that mean? It means here I am going to milk decorator is on top of, I think that's what it means by wrapping, on top of this coffee decorator. So it's a decorator on top of a decorator. And so it's going to have these methods available to it. Okay. So now let's just kind of write this out. Public milk decorator, so the constructor, so coffee, okay. Super, all right. Coffee, yeah, it's actually, yes. Okay, so super, I know this concept kind of from Python, okay. But I'm not extremely confident in my understanding. And I think it's fairly obvious. My understanding of object-oriented programming is essentially zero. Or at least it was before I started my YouTube channel. It was just zero, like completely zero. Because when I was in school, my degree is electrical engineering, but I took some computer science classes, and it was all just functional programming. And you would do Python, but it wasn't actually object-oriented Python. It was just procedural Python. And you would do like, you would call methods on certain things, but that's not the actual idea of how do you actually implement object-oriented structures. So I had never touched that. And then at work, I do embedded systems. So it's just like electronics and looking at data sheets and just putting values into registers. So it's not object-oriented. So that's why in these videos, I'm always stumbling over the object-oriented methodology, and that's why I try to attack it head on and really understand these concepts. So we're going to be looking at super as well. Okay. Number 2 is, what exactly does the super do? Okay. I believe what it does is it takes coffee, it takes the object passed in, okay, and then it will pass this coffee object to the parent class's constructor. So it goes to coffee decorator here and passes that in here, and then it performs this operation and then returns back to here, right? Like then it comes to the next line and does whatever it wants to do here. I'm pretty sure that's how it goes. I just want to be sure. That's why I'm playing around with these ideas and concepts. Okay, so we do that. I think it just instantiates it to the parent class. Okay. I also noticed we didn't like save it. We didn't say like coffee, like protected coffee. Okay, so public. And now we're going to do string and do the exact same thing that we did up here, get description, okay? Get description and return decorated coffee. Again, I did not, yeah. No, that's a different error. I did not instantiate that. Okay, so this is present. Why? Because we are inheriting from coffee decorator, okay? And coffee decorator has this class here. So the child class has the class of the parent, or has the member variables and methods of the parent. Okay, that makes sense. And that's why we didn't need to instantiate it again here. Wait, hold on. I'm going to get rid of this one and get rid of this one. That's why we didn't need to instantiate it here. Like, we didn't need to create a new member variable here. We just passed it into this constructor, and the constructor kind of saved it in its own parent class, but then that parent class we've inherited from that, so we have access to that variable. Okay. Get description. So I can just do a return coffee dot get description like that. Okay, so now we can do this thing here. So hold on, there's two classes here, two public classes here. What's going on? Let's see if it causes an error. All right, so public double and get cost, yeah. And we can just do return and then decorated coffee cost, and then we're adding 5 to it. So decorated coffee cost dot get cost plus 0.5. Okay, so we're taking what the parent class, so we're taking the base class here, and we're saying, hey, do return this get cost. So it's gonna return a cost. So it returns a cost, And then we are returning an addition to that cost. So we're increasing the price of the base class. So the base class has a certain cost. It's going to give that to us. And then we say, okay, great, that cost plus this little extra, and return that. Okay. So now, it's one of the interesting things, I'm kind of curious if this is going to give me an error. Public class, okay, sugar, okay, extends coffee decorator, like this. Yeah. Defined in its own file. Yeah, what? I thought that was going to be the case. Public client code. Okay. This is like the main. Yeah, here's main. Okay. Okay, so this is question number 3. Paste that in there. Why did you put these two public classes in their own, in the same file? Shouldn't they be in their own separate files? All right, so we're gonna get that 1, 2, 3. Actually, I should just look at the. Let's just assume that we're doing this in a separate file. I kind of want to do this client one. So copy this, and it's called Sugar Decorator. Okay. So then decorator.java. Okay. And then I say extends coffee decorator. Okay. Coffee decorator. Awesome. Public sugar decor. Oops. Sugar decorator. Okay. And then same thing here, coffee, right? And then we're gonna put the thing here. So super, and then coffee. Yep. Oops. Coffee. Come on. There we go. And now we can just do this one. Actually, I'm just gonna copy and paste because we've done it so many times. We're just trying to learn, right? Like that's the point of this, is to learn. So this one, the only change is we are adding 3 to the when we get back, and then this one we are adding sugar. Okay, so the description we're just appending this to the string. Okay, awesome. So let's do one more, and now we're going to call it coffeeshop.java, and here we're going to have public class coffee shop, which inherits from nothing. Okay. So now what I want to do is have my main function. Okay, awesome. Okay, so here we go. Public static void main. Awesome. And then string args. Args. Okay, let's go. So we want coffee is equal to, and we'll need to investigate this, simple coffee, okay? So somehow I am able to, so this is an interface and this is an object, yes, but it implements from coffee. So it has this interface type, this contract. Okay, so I can capture it here. I can say like you are just of type this interface. Okay, so system dot out print line, and then we say coffee, this coffee dot get description. Okay, and then we do plus and then the price. Okay, so plus $, and then plus again. Yeah, okay. It will be coffee dot get cost. Okay, like that. There we go. That should be good. And then we have these decorators, and we pass in that coffee object. Okay, so now what I can do is coffee equals new. So we're creating a new object, right? Milk decorator of coffee, correct. Then coffee again equals new sugar decorator of coffee. Okay. Equals new sugar decorator of coffee. So we're doing the same thing again. Sugar decorator of coffee. Okay. And then we're just going to do this system print line down here. Okay. All right. So do you want to know something kind of funny? I'm going to ask another stupid question. How do I run this? So, because when I use the Spring Boot, I always just do, I always just launch it from Spring Boot itself. So I know that I need to compile this. Is it just Java C? And then the project, I forgot. So we'll need to look that up. And I also recognize that yes, we didn't even go and look at these design patterns here. We haven't even looked at that yet. Okay. What are the other grouping? Let's just look at it real fast. Design patterns. So we have the singleton, factory, abstract, builder, prototype. Okay, so all of these are part of the creational, right? Okay, so this is the group, is creational. Singleton enforces that our object is like singular. Okay. Factory delegates, so this like creates family of related objects. Builder, constructor, complex objects step by step. Okay. Prototype. I mean, there's a lot to learn here. So decorator here, this entire video is about decorator, and this is just one of the many design patterns. So this is a structural design pattern. Then we have adapter, convert one interface to another. Okay, bridge, separate abstraction from implementation, composite, treat individual and group objects uniformly, facade, flyweight, proxy. I mean, now this one is behavioral. Observer, strategy, command, chain of responsibility, state, template, method, iterator, mediator, memento, visitor, interpreter. Oh my goodness. Okay, so there's a ton that we're going to have to be kind of just like moving towards trying to understand. Okay, so we're going to have to keep making a lot of these videos. All right. So let's, I'm gonna take a sip of water. So, what does the protected keyword mean? In Java, protected is an access modifier that controls visibility of class members. So, field method. So, same package and subclasses. All right. So it means that the subclasses can see it, the same package can see it, but you can't see it outside of those. Okay, fine. That's fine. That's whatever. What does super do? It's a special keyword in Java that calls the constructor of the superclass. Okay, I was right. I just wanted to make sure. You're right. This will cause an error. Okay, so we corrected it, and we already did that. That's fine. Okay. So, now that I have created all of those files that you gave me, how do I actually compile and run it? Okay. All right. So I can't do, what was the way that I did it with Spring Boot? It was like Maven build, and then it just like does it. But now I can't do that, right? Because it's not a Maven package. Okay. So step one is make sure that they're organized into the same folder. Yep. Step two, compile all of the files. Okay, so I just do this Java C, and then I pass in the wildcard.java. Okay, so let's just do that. Terminal, new terminal, and then close this one out. Okay, ls, and it should have all of the, whoop. Hold on. Do I do this from the root directory, or do I have to go in? Make sure your files are... I mean, just intuitively, I feel like I would need to go into my app, but I kind of want to try it without doing it. Right, Java C, and then wildcard.java. Yeah. So we need to cd into, I need to make sure that I do not, that's a, so I'll tell you a little funny story is one time I was doing one of these videos and I said that exact phrase. I said the letter C, and then I said the letter D, and then I said, where am I? Okay. Because I was trying to figure out which folder I was in. So I said, this letter, where am I? Well, the letter C combined with the letter D together sound very similar to the Apple Assistant, okay, which started listening. And then it heard the question, where am I? And then it proceeded to give me the exact coordinates of my location. So, good thing these videos are not live, right? It's like, oh, you are at this exact location. And I'm like, thank you for that. But anyways, so we're going to change directories into calm and my app. Okay, so now I do ls and I have all of these, and then I can do the Java C wildcard dot Java. Okay, there we go. And now what it did is it just created this like class file, and that is the compiled version. Okay, so we compiled everything, run the main class. So then I can do Java and then of the main class, which will be right here. We won't be able to see it because it's... wait, hold on, we can't see it. What? Coffee shop.java. Here, get description. That's kind of interesting. I was expecting source code is, hold on, what does this say? Source code is decompiled from a .class file. Okay. It's actually a little bit weird. I was expecting to see source or like binary code. That's why I said, oh, we won't be able to see it, but then we can see it. Okay. So I do Java and then run this coffee shop. Could not find or load main class coffee shop. Okay. Let it do its balancing. All right. Yes, I know. So file structure check. Each file should, yeah. Okay, here. Classic Java issue related to packages and file structure. Let's walk through it. All right, so your class coffee shop is declared inside of a package com my app, but you're running it without referencing the package. Java expects the class to be in a folder structure that matches the package name. Open coffeeshop.java and look at the top. If it says this, yes, it does. Right? Let me just coffee shop .java. Yes, it does. Okay. Then Java expects the file to be in a folder like this. My app, com, my app, coffee shop, okay? From inside the com folder, run this. Okay. Then, so should I do this inside of my com is run that command here? No. So now it's saying Java my app dot okay. Package name Java and for man. I kind of forgot why I dislike Java so much. I should have done it in C#. Okay. Awesome. So I'm just gonna do ls. Can I do ls my app like this, like that? There. So I'm just gonna copy and paste this so that I can give this more context. Let it bounce around. So yeah, that's where I am. You need to go up. Okay. So I need to do it from the main thing. So now do I have to do this and then say calm? But I mean, this doesn't make any sense. That doesn't make any sense. That doesn't make any sense. Why? Why does the command of execution have any bearing on the functionality at all? Okay. Oh my goodness. Okay, so it worked. I changed directories into the whatever top level and then did the command this, but I have no idea why the location at which I call the execution of a class will have any difference in the running. Is there something different that is passed in as a parameter? What actually happens when I run command? Okay, let's kind of see about that. And then we got it here, right? Then we need to kind of look at this and understand, okay, well, what actually happened here? So I said I should have done it in C#, but actually it's really good that we did it in Java because it's kind of exposing a lot of those things that I need to know, right? I need to learn this. So it's a wonderful learning opportunity. Just sometimes when you're wanting to do one thing, but then you just keep getting pulled towards here or there or there, and it's like, come on, I wanted to learn this thing here, but I'm learning like 10 other things in the peripheral. Okay. So come here and look at this. Confirm. Not here. Is it? Okay, yeah. So, digging into the JVM, Java Virtual Machine, locates and loads classes. The location from which you run Java, so the Java evokes the Java Virtual Machine, okay? What happens when you run this? You're telling Java Virtual Machine, start executing the class name coffee shop inside the package com app, okay? And look for it in the current working directory as the root, okay? So the JVM breaks down class path root is set to your current working directory by default, JVM, here into a file path, okay? It searches for the class in the relative current directory. If it finds it, it will load and run main. Awesome. Why directory location matters. If you're inside of com folder here, Java, so it doesn't look for it correctly. That right there, that makes sense because you're doing it from the wrong directory. But what I'm meaning is, if I am inside of com and I don't run this portion, I just run the other portion. Okay, which doesn't exist. Yeah, of course that's gonna fail. But why did it fail when I was inside of com and I did this here? Okay. All right. Is something passed in it as a parameter? Yes, indirectly. JVM uses the full qualified class name here. Okay. Yeah. So it should be able to find the shop main. I'm just gonna make sure Susie sent me a message. I'm gonna make sure everything is okay. Okay, cool. I just wanted to make sure everything is all right, and then I can respond after we finish this video. So, where were we? Here. Okay. It seems intuitive that if you're inside the com folder and run this, it should work. But here's the key. Java doesn't search relative for your current directory in the way you might expect. It treats your current directory as the root of the class path, not the starting point within the file structure. Okay, so when you run this from inside the com, Java interprets this as look for app coffee shop class inside the current directory com. Yes. So what it's really looking for is okay. So there's one thing that I remember doing, and I remember I think I did like an hour and a half long video trying to fix this one error. I can't remember which video it was. It was one of the first videos that I did on the series of like learning Java. Okay. And I remember, I think the solution that I came up with was I needed to do com for my package. Or I needed to like delete this com. Or I had to do something strange to this com here. Okay. I don't know why that solved the problem. But at the time, I was mainly focused on trying to understand all of the other things. Like there was a lot going on, right? So I just said, okay, great, it's working. Let's move on. Okay, so that just reminded me. I never thought about it again until just now when I saw this com. I want to kind of investigate it more right now, but I also kind of want to look at the design pattern. I want to look at the decorator. So awesome, that's great. I'm happy for you. Is it different than C#? Oh, yeah. So let's see, which becomes this. That's why it fails. All right, so we'll look at this a little bit later. Yeah, well, I'm gonna look at this later. Um, let's kind of see what actually happened. So I don't even know if I need this anymore. So we say here we got this print line and we have a description and we have a cost. Description is 2, cost is 3. No, sorry. Description is simple coffee, cost is 2. So we came here, we created a simple coffee. I wish I could kind of filter for. I don't want to see the dot classes actually. So no, simplecoffee.java. Okay, so this is, we created this actual. This is like a, what would the terminology be? Concrete, right? This is a concrete class. It has an actual implementation of get description and an actual implementation of get cost, which is part of our contract to say, hey, I implement coffee. I have a contract and I fulfilled that contract right here. I have my implementation right there. Okay? So my coffee shop is here and it's, no, that's the class. Simple coffee shop here. Okay. So I have this object and I'm able to evoke the methods get description and get cost, and it operates as we would expect. Okay. So now what I do is coffee equals new milk decorator coffee. Okay. Great. So now let's kind of look at what happens here. So I have this milk decorator coffee. So I pass in coffee here. Now extends, which means that this is that abstract class, right? Coffee decorator, abstract class, okay. So I come in here and I pass in that object, okay, to the parent class here. Now I have this decorated coffee, implements coffee, and then, so it just has this new implementation. At the base case, we come here, okay? But then when I call here, I didn't even change this, right? Like I didn't even do like description plus whatever, milk, right? So if I do this, I save this, and then I come in here, so ls, so then I need to do what? Java C, and com my app, everything Java, was that the syntax? And then Java com coffee shop. So now it should say milk. Okay. That, but okay, so that's how I'm able to change the functionality. I see that. Okay, fine. come back here. So I'm adding on things to my object. So my object still has that method, which is like get description, but I'm just adding on. So I'm calling it from the decorator, and then it calls it and calls it and calls it, and it hits that base case, which is the original coffee, like this actual concrete object. And this object returns something. And what does it return? Simple coffee not this one, it's a class. Simple coffee here. It returns simple coffee, okay? And then it gets passed back up to the next one that we called, which is it would have been this milk, right? And then it would say like simple coffee milk, right? That's what we get here. But because we have 3 like nested decorators here, what we do is we hit our base case, then we pop out, and then we say this string is simple coffee, and then add on the phrase, I guess this is the lowest one. So add on the phrase milk, okay? And then we pop out of that one and we add on the phrase sugar. And then we pop out and add on the phrase sugar again. So milk, sugar, sugar. And then each time we increase the price. Okay, and I guess, did we not increase the price for milk decorator? Oh, we did. 0.5. So we have the 2 here, and then what was the sugar decorator? 0.3. Oh, okay, that kind of makes sense. Okay, I see. Okay, so you're able to nest them. I kind of understand. I mean, it's good to play around with it. I think I need to continue to play around with it. I'll probably make another video just playing more around with this concept. And then I also need to make another video talking about the problem that we just encountered here with the location of execution within the Java virtual machine. But I think I'm going to take a little bit of a break, and yeah, so thank you guys for watching this video. If you liked it, subscribe. I would love to have you along for the journey, and hope everyone is having a good day. My name is Timothy Lee Grant, and goodbye. Now, hopefully this video actually recorded, because at the very beginning I froze up, and I'm always cautious when that happens, and so hopefully I didn't just lose the entire, I don't even know how long I did this video for, but hour maybe, I don't know. Anyways, see you guys.